Hello and welcome to this video lesson which covers the introduction to vectors. Some of the prior knowledge that will be useful for this lesson are trig ratios and basic geometry. Let's start with this example where we got a box being pushed by two different people and we've drawn two different arrows signifying the force that they're putting on the box. We can extract two pieces of information from this image. One is that the arrow size in the first one is much bigger than the second one, and that kind of tells us the size of the force or the strength of the person. The longer arrow indicates that the person is putting more strength into pushing the box. The second piece of information that we can extract from this image is the fact that the direction of the first force is to the right and the direction of the second force is to the left. Note that these force vectors are represented by a ray where the point is the tail of the vector and the arrowhead is the head of the vector. Let's show you some terminologies that are used for vectors. So in this case, we do have a person pushing a box. They're putting a force of 10 Newton. We're taking right to be positive and we're taking left to be negative in this case. Now there are many different ways to represent vectors. In this case we're using the letter F for the force, and you can see that it can be represented with an F with an arrow on top, or it can be a bolded F. Most textbooks will use bolded letters because it's easier to type that way, but when we're writing things down it is difficult to bold letters, so we will use the letter with an arrow on top. Now this particular force is 10 newtons and we can see the direction is towards the right direction from our coordinate system, and we can write this as negative 10 Newton as well, but if we write negative we have to write it in the opposite direction, which is left. Now for the arrow on top of our letters, we can use the arrowhead, which is two-sided or one-sided. For me personally, it doesn't make a huge difference, but make sure that your teacher is okay with whichever method you're using. Now every vector needs to give us two big main information. One is the size and one is the direction. In this case, 10 is the size of our force, n is our unit, and r, written in square bracket, in this case is the direction. The direction can be written in different ways, and vectors can be written in different ways as well, which we will discuss in the future. Now whenever you're writing the size and the unit, make sure you leave a space between whatever your size is and whatever the unit is, and that's the convention for writing proper units. Note that I didn't do this properly for the first case, but for the second one I did fix it, and this is to distinguish 10n, which is 10 multiplied by n, versus 10 Newton, where n is the unit Newton. Now let's discuss vectors in two dimensions. In this case we have a person who is pulling a box or a cart at an angle of 20 degrees to the horizon, and the force that the person is putting is 80 newtons. When dealing with questions which involve vectors, you can always choose your own coordinate system. In this case I have chosen a coordinate system where right is right, left is left, up is up, and down is down. I'm going to draw that coordinate system and I'm going to draw the force that's acting on the object, and you can see that the force is 20 degrees with respect to right and is moving towards the up direction. We can write this force in many different ways. One way is to write that the magnitude is 80, that the unit is Newton, and in square brackets we're going to start with the direction that it's pointing at. In this case we start from right and then we go 20 degrees towards the direction up. Another way of writing this is 80 Newton starting in the up direction and then moving 70 degrees towards the right direction. We can alternatively write this in a different way by drawing the arrow in the opposite direction and using a negative direction. And this can be negative 80 newtons starting in the left direction, turning 20 degrees towards the down direction, or negative 80 newtons starting in the down direction and then moving 70 degrees towards the left direction. Now this is a convenient way of writing a vector because it gives all the information to us. However, it doesn't give us the component of the vector, so we can see that the vector is, for example, in the right direction and up direction, but we don't know exactly how much to the right and how much in the up direction. So an alternative method of writing vectors is called the component form, and it will give us the size of the vector in each of those components. In this example, we can see that our vector is 80 newtons and it has both right components and up components. We can see based on the image that the right component is slightly larger than the up component. So I'm going to use purple to write the right component. This can also be called the horizontal component or the X component. And I'm going to use pink to write the vertical component or the up component, or alternatively the y component of the vector. Now, how do we find the magnitude of those components? Well, we can use trig ratios. We know that the opposite side to the angle is the up component, so we can write sine theta is equal to the up component divided by the hypotenuse, which is the magnitude of the actual force. And if we rearrange that, we get that the up component, its magnitude is equal to the magnitude of the force times sine theta, which is 80 sine 20. We're going to use a similar method to find the right component of our force or our vector. So cosine of theta is equal to the right component of the vector divided by the magnitude of the main vector, the 80 Newton. And if I rearrange that, the right component is equal to force times cosine of theta, which is equal to 80 times cosine of 20. One very important takeaway from this is that the magnitude of the components can never be larger than the actual vector. So in this case, the right and the up components are smaller than 80 Newton. There are many different ways of writing vectors, and in this lesson we have covered some of them. Now, in terms of component form, if the force is 80 Newton, write 20 degrees up, then one method of writing this in component form is using square brackets, and we will write the horizontal or the x component on top and the vertical or the y component at the bottom. This is a method that's often used in the IB curriculum. An alternative way of writing component form is using pointy brackets, and we can write the horizontal component first, followed by comma, followed by the vertical components. Okay, now let's look at a couple of examples. In the first example, we need to determine the component form of this lovely vector. This vector has a magnitude of 20 meters and is 30 degrees from the north or the positive y direction. The first step of solving these questions is to set up a coordinate system. I will use up as my positive y and right as my positive x. I will then break my vector into the two components a y and a x as shown. The x component is the opposite to the angle, so I know its magnitude is equal to the magnitude of the vector, which is 20 multiplied by sine of the angle, which is sine 30, which will give me 10 meters. And for my y component, that is adjacent to my angle, and therefore I will use the cosine, and the magnitude of the y direction is equal to the magnitude of the vector 20 multiplied by cosine of 30, which is 10 root 3, which is approximated to 17.3 meters. I will write this as component form by putting the horizontal component on top and the vertical component at the bottom. For the second example, I will be writing the vector b, which is 75 Newton west 20 degrees south, in component form. The first step will be to draw out the vector. So I know that the west side is a little bit bigger, so I will draw that a little bit bigger. And I will draw my vector. It is 20 degrees from west towards the direction of south. I will then label bx and by, and I know that in this case the magnitude of my vector b is 75 Newton, and I will use straight line brackets to indicate that. Okay, to find bx is adjacent to my angle 20, so it will be the magnitude of the vector multiplied by cosine of theta, so that's 75 sine 20, which is equal to approximately 70.5, and my by component is opposite, so 75 sine 20, which is 25.7 approximated. Now what I haven't done yet is to set up a coordinate system. So now I have done that. My x direction is east, my y direction is north, and I'm going to take those to be positive. I know that my x component is actually in the west direction, which is opposite to what I've indicated as my positive, so I'm going to use that as negative east. And I know that my by component is in the south direction, but I've used north as my positive, so my y component will also be negative. So given that, my b vector is equal to, approximated at negative 70.5 Newton and negative 25.7 Newton, 70 for the horizontal and 25.7 for the vertical component. I am going to leave you with a few practice questions to try out, and you can pause the video and write these down and try it on your own and see how well you understand the concepts to this lesson. Now here's a summary of everything that was covered in this lesson. You can also pause the video to view this as well. And thank you for watching this video. I hope that it was helpful for getting an introduction to what vectors are, and I will post future videos for more detail on mathematics of vectors.